In the last lesson, we looked at the algebra part of our circles unit. We looked at equations and graphs. Here, we're going to get into the pure geometry of it. And as is often the case with geometry, we've got a lot of vocabulary we're going to have to look at. So this lesson is called arcs and central angles, and those are the two things we're going to be dealing with. So we have the definition of central angle first. That's an angle whose vertex is the center of the circle. So if you look at this diagram in the lower right, we have an angle BAC whose vertex is point A, which is at the center of the circle. So angle BAC is a central angle. So when you see that vocabulary, it's just talking about an angle that has a vertex at the center of a circle. And these are important because of the relationship they have with arcs. So arcs are a piece of the outside or a piece of the circumference of a circle. And I'll show you a couple examples in a second because you have two types of arcs and there's a specific way you would write each one. But if you look at the picture here, we have a circle, and if you look at the outside of the circle, part of it is in red, part of it is in blue. And the red part is an arc. It's a piece of the circle. Now, it goes most of the way around the circle, but it's still just a part of the circle, so that's an arc. The blue part is also an arc. So we have two types of arcs, like I said. The first type is the minor arc. And these arcs are created by central angles. So when you have a central angle, it's going to come out, it's going to hit the circle in two places. So this angle we have at BAC, it hits the circle here at B, and it hits the circle at C. And when it hits the circle, it creates two arcs. And the smaller of the two arcs is called the minor arc. And the way we would label the minor arc is we just look at those 2 points where the angle hits the circle, so B and C. And that's the name we give to the minor arc. And the symbol we use is a little curved line, like a little arc goes over the top of it. So that's arc BC, and that's a minor arc. And on the picture, that's the blue part. The major arc is the big arc that forms when you, so here, if we just go from B down to C, that gives us the minor arc. But if you go the other way, if you start at B and go up and go all the way around the circle, that's what's called your major arc. It's the bigger of the two arcs. And for a major arc, when you give it a name, to be really clear about which arc you're talking about, you want to use 3 points. So if you look at our diagram here, we have this other point, point D. And point D isn't connected to the central angle. It's just this extra point kind of floating on the outside of the circle. But we need to have a point out there to be able to name the major arc. So for our major arc, we're going to call it B, D, C. And the idea is we would start at B, we would go backwards through point D, and then back around to point C. So this would be the red part of the circle. And again, we put the little arc over it, the little curved line to say that it's an arc. And that's our major arc. That's the red part. So that's the vocabulary that you're going to need to know for this lesson. And the other thing I want to point out here before we move on to the next slide and get to some examples is arcs, much like angles, can be measured in degrees. Now, the red arc and the blue arc, they have a length. And we could, if we knew something about the radius or the circumference of the circle, there would be ways we could calculate the length of the blue part, the length of the red part. But we can also measure them in degrees, like we would with angles. And the way that would work, and we're going to see this more on the next slide, if this angle BAC is 80 degrees, then the minor arc, so arc BC, the blue part, is also going to measure 80 degrees. So when you measure an arc in degrees, it's always going to have the same the minor arc, will always have the same measurement as the central angle. And let's look at a little bit more of that, and we'll see what we can do with the major arc too. So like I was just saying here, arcs can be measured in degrees. And like we just saw, a minor arc always has the same measure as the central angle. The major arc, though, you have to remember an entire circle, the degrees of an entire circle is 360. So it's 360 degrees around the whole circle. So to find the major arc, you would take 360 minus the measure of the central angle. Or in other words, you would take 360 minus the minor arc. So to see what I'm talking about, let's look at this example. It says, identify and find the measures of the minor and major arc of angle APB. So angle APB is a central angle right here, and it's 84 degrees. So first I want to identify my arc. So my minor arc is, I'm just going to take the A and the B. Remember, you only need 2 points for a minor arc, and put the little symbol over it. So my minor arc is going to be AB. And let me color code this so it's really clear which one we are talking about. So let's do this in like orange. So our minor arc is going to be the orange arc. And then our major arc, for the major arc, we've got to go backwards around the circle. So we're going to start at A again, but this time we're going to go backwards, and we're going to go through point C and all the way back around to point B. So that's our major arc, is that big arc that's in blue. And so we got the major arc, and we would write that as ACB. So we still go from A to B, it's just we go backwards through point C, and that's in blue. Oops. And that's in blue. Okay, so let's now find the measurements of these arcs. So for arc AB, the minor arc, it's really easy. The measurement of AB is going to be the exact same as the measurement of the central angle. So if the central angle is 84, the arc is also 84. So we would say measure of arc AB is equal to 84 degrees. Now let's find the measure of the major arc. So the major arc is the blue arc, and it takes up the rest of the circle. So what we're going to do to find the measure of that is we're going to take 360, that's the entire circle, and then we're going to subtract out the minor arc, or subtract out the central angle. And we're just going to see what's left after we do that. So when we subtract, you should get 276 degrees. So the idea is if this part right here, the minor arc, is 84 degrees, then the rest of the circle, the major arc, would have to be 276 degrees. So we can say the measure of angle, or arc ACB, the measure of arc ACB is 276 degrees. So for a minor arc, it's always the same as the central angle. Just copy that number down if you know what it is. For a major arc, you take the central angle and you subtract it from 360, because the major arc will cover the rest of the circle. All right, so we're going to go over a few more examples, and these are based on the same ideas, the same stuff we've already learned. It's just they're a little bit more complicated problems. They're presented a little bit differently. So I want to make sure we go over a variety of them so you get the idea of all the types of problems you might have to do. So one thing it's important that came up very early in the year, and it's been a long time since we've had to deal with this, although I think we dealt with it some when we were doing proofs. Sometimes your angles, instead of being labeled with 3 points, like saying like angle ABC or angle CAB or something like that, sometimes they're labeled with numbers. So here on this example, it says identify the minor and major arc of angle 3. So angle 3, you can see the 3 in the circle, and that is talking about this angle right here. So it goes into the center of the circle, it goes out to A on one side, and it goes out to C on the other side. So that is angle 3 right there. So if we want to identify the minor and major arc, we're going to use those 2 points, C and A. So the minor arc again, you're just going to write down those two letters and put the little arc over it. So that's going to be the short distance from C to A. For your major arc, we have to go backwards the long way around the circle. So we have this extra point here, B, that we're going to have to use. So we're going to start at C, go backwards through point B, and back around to point A. So the major arc is going to be CBA. So again, minor arc, you use 2 points. Major arc, you use 3. On this next example, we're starting, instead of starting with the angle, we're starting with the arc. And the, sorry, there's already that color of red. I wanted to get a distinct color. Okay, so for whatever reason, when you do the equation editor on PowerPoint, it doesn't really have a good arc symbol. So this really should be a little more rounded. For some of the reason, you get all the algebra and calculus and statistics symbols, but you don't always get all the geometry symbols. But anyways, this is talking about arc STV. So the idea is if you start at point S and you're going through point T, so you're going to have to go this way, through point T and around to point V. So that purple arc I just drew is the arc that we're talking about. And you want to know what angle goes with that. What angle creates that arc? So the idea is to do this, you just take your first point and your last point, so the S and the V. You start at either one of them. It really doesn't matter. I'll start at V. You go into the center of the circle, which is Q, and then you go out to the other point. And that's going to give you the angle, the central angle that creates that arc. So your angle would be angle V, and then into Q in the middle, and then S is your last point. So you could also write that as, and this is probably the easier way to think of it, S, Q, V. So one way you can do these, if it gives you an arc like this, especially an arc that's labeled with 3 points, and it wants to know what angle creates that, just take this middle point. So here's, it's a T. Get rid of that and replace it with the center of the circle. Because if an angle is creating an arc, it has to be a central angle, which means the middle letter, the vertex, has to be the center of the circle. So you'll take the 2 points on either side, the S and the V, and it doesn't matter which order you put them in. You could put the V first or the S, and then the point in the middle would be the center of the circle. Put a little or there to say that those are both correct answers. All right, couple more examples. This time we're not just identifying, we're trying to find the measure of something. So the little m, we've seen this before with angles, the little m before something means measure of. So you're trying to find the measure of that. And with the types of problems we're doing, you're looking for the measure in degrees. So the arc it gives us here is CFD. So what we need to do is start at point C. We have to end up at point D, but we have to go through point F. So this is going to be a major arc. We're going to have to go around the back way to be able to go through point F. So that's a pretty big arc that we just made there. And we want to find the measure of that. And remember, the measure of arcs is related to the measure of angles. And this can get kind of complicated, and a lot of times you're going to have to play around with some stuff. So you have to use stuff we have done before. You're going to have to kind of dig into your memory and use different things and play around with it to find your missing angles. So what I really need to know here is I really need to know this angle, this central angle right here. If I know that angle that I just marked in orange, then to find the measure of my major arc, all I would have to do is subtract that angle from 360. But I don't have any information about that angle. It's next to an 81-degree angle, but those two angles don't make 180. They don't make 90. There's nothing I can really use there. So you have to really look closely. And so the two big things I would look for is see if you have 2 or 3 angles that make a straight line first. And if you look at this diagram, we have a straight line right here. And what that tells us is that these 3 angles have to add up to 180. And a lot of times that will be the information that you will need to be able to find a missing angle. On this problem, though, we have 2 angles we don't know. And we really know nothing about them. We don't know that they're the same. We don't know, they might be the same, they might be different. We really don't know. So if we have 2 things we don't know, we're kind of stuck. We can't really do anything there. So on this one, just seeing that straight line doesn't really help us. So the other thing you want to look at, which is a thing that's come up a lot in other units, is vertical angles. So if you look at this 135, remember vertical angles are angles you get by lines that intersect each other. And they're the angles that are across from each other. So if you look at those 2 intersecting lines that I just outlined in green, that 135 degree angle is a vertical angle with this angle right here. And the thing we know about vertical angles is they are always congruent. So this angle right here, this angle that includes the 81 and the orange angle together, is 135 degrees. Just like the angle on the other side, because they're vertical angles. So now what we want to do is, to figure out our missing angle here, the one that I marked in orange, we need to take that 135 and subtract the 81. And when we do that, we get 54 degrees. So what that means is this angle, the one we were looking for, is 54 degrees. And we know that because if we take 54 plus 81, we get 135. And we know those 2 angles, when we put them together, have to be 135. Okay, so 54 degrees is the measure of that angle, which means it's also the measure of the minor arc. But we want the major arc, so we have one more step. And so our last step is to take that 54 degrees and subtract it from 360. And when you do that, you should get 306. And so our major arc, the one we are looking for, the big arc, is 306 degrees. And I will say, of the problems you'll get on the assignment that goes with this, this would be one of the very most difficult problems. So that one's a little trickier. There's a lot going on there. But the thing to remember, though, is a lot of the stuff you had to do is stuff we have done already. And it's just being able to see where that's coming into play in a different type of problem. All right, number 12, it wants us to find, this time, the measure of an angle. It says find the measure of angle SPQ. So I want to outline that to see what angle we're talking about. So I go SPQ. So it's this angle here. And the way that this circle is drawn, that angle I'm looking for, SPQ, is broken up into 3 different angles. And one of these angles is 86 degrees, because we know the angle always matches the minor arc, so it's 86 degrees. The other 2 angles, I don't know what they are, but I do know that they're the same, because these little red lines, these little red arcs, those indicate, and we've seen this before when we were doing proofs and congruent triangles and stuff like that, those little lines mean that those 2 angles are congruent. They're the same as each other. I'm going to call them X. So this is X, and then this is also X. Okay, so what I need to know, to find the measure of angle SPQ, I need to know this arc that goes from S up to Q. So I need to know the measure of that. And to get that, I need to know the measure of these 2 angles here. Because I know at 86 already, but I've got 2 more angles I've got to find. So the way I can do that is I know the entire circle is 360 degrees. So what I'm going to do, and there's different ways you could do this. You could set up an equation, but what I'm going to do is I'm just going to start subtracting stuff. So I'm going to take the 360, and that's the whole circle. I'm going to subtract 60. Get rid of that. That gets me down to 300. Now I'm going to subtract 154. And when I subtract that, I get 146. So if I get rid of all this, what's left is 146 degrees. And honestly, I was going to actually record this again because I see a much faster way of doing this, but I will just kind of explain to you what I'm thinking here. What I was going to do is figure out what x was and then add those two x's to the 86. But now that I've started this, and now that I've actually worked it out this far, I can see I don't need to do that, because once I subtract the 154 and the 60, everything that's left is this angle that I'm looking for. So I'm looking for SPQ. SPQ is whatever's left after I subtract all this stuff over here. So I don't even need to find x. I can just go with the answer I already have. So I can say angle of SPQ, the measure of angle of SPQ, is 146. So sometimes it ends up being a lot easier than it looks at first. So I'm going to go ahead. Let's finish it the other way, just in case there's problems where it doesn't work out that nicely. So let's go ahead and say we have 146 for these three angles. So we have 86 plus x equals 146. And so we're going to solve for x here. And we're going to get x plus x equals, when we subtract there, we get 60. And so here you can see, okay, what plus what equals 60? What plus itself equals 60? And so x would be 30. You could also say 2x equals 60 and divide by 2. The x is equal to 30. And then if you take 30 and add it to another 30, because we have two x's, and add it to the 86, you do end up back at 146, which is the answer that we got. So that angle is 146 degrees. And so working this problem out, you already know circles are 360 degrees. And so really, it's just a subtraction problem. The one new thing you need to know is that the measure of arcs are always equal to the measure of the central angle that makes the arc. So that 154 is not only the measure of that arc, but it's also the angle, or the measure of the angle RPQ. And 60, not only the measure of that arc, it's also the measure of SPR. So the arcs and the angles have the same measurements, so you can use them interchangeably. So that's what we're doing on arcs and central angles. So good luck with that. Remember, keep an eye out for things like vertical angles, and just recognize that a lot of this is just going to be addition and subtraction. The trick is just going to be figuring out what you're adding and subtracting.